Aloha, Richard Halverson here, and we're doing graphs. And in this video, I'd like to cover weighted graphs, section 21.11. Let's see. So here we are. And so a weighted graph associates a weight with each edge. And when you're calculating, when you're traversing, you usually add up the weight or the cost of the particular edge, and that's how you come up with shortest. It's not just distance anymore, but it's actually there's a weight associated with each edge. Miles or something like that. So a graph's edge weight or cost represents the numerical value between the vertex items such as flight costs between airports and so on. So that's what's represented here. Make sure you understand there's weights there's weights for the graphs can be undirected or directed graphs. The graph's weights indicate the number of times coworkers have collaborated on projects. How many times has Raj and G teamed up? Raj and G looks like 4 times. So anyway, make sure you understand weights and path length in weighted graphs. So we can say the length is the sum of the edge weights. No, a little bit different definition for the term there. And path length and shortest path, it's you consider the weights or the lengths or whatever whatever the numbers are supposed to designate. There can be negative weights or negative edges, and then there's cycles and so on, negative cycles, and so it's pretty much what you'd think. Let's do the challenge exercise. It's a challenge activity here. Okay. Find the weight of each of the following edges from B to D. B to D. Well, I would say that is 6. 6. From B to D, from C to D is 8. And from C to B is undefined. There's no edge from C to B. There's an edge from B to C, but not C to B. So this would be undefined. All right. Get it right? Oh, good. All right, what's the next one? Given a path B, E, A, C, what is the length? B plus 4 to get to E. Let's I can pull up a little whiteboard here. I can pull up so from B to E is 4, and then E to A is 2, and A to C is 5, and that's it. B to E. Okay, so that would be 4 plus 2 is 6 plus 5 is 11. I think that's the answer. Four plus 2 is 6 plus 5 is 11. Okay. What's next? The shortest path from C to E has a length of, from C to E, excuse me, sneeze. All right, the shortest path from C to E has length of C to E. the shortest path from C to E. Well, you can go 7 minus 1 is 6, or you can go 3 plus 1 is 4, plus 2 is 6. 6, the shortest path from C to E. Is there another way to get to E? You can go to A and then to E, and you can go to D and then to B and then to E. So I guess it's 6. The shortest path from C to D is length 3. Okay. Why do I have a feeling I may get something wrong? All right. Oh, very good. All right. Anyway, all right, what's next? The cycle length for ADBCA, that would be, let's see. Let's just get rid of this. Let's see, A to D, which is -3, and then from D to B, which adds 2, and then from B to C, which adds 1, and then back to A again, which adds 9. So it's -3, 0, 9. The answer is 9, right? Because when you add up 10 minus 1 is 9. Total is 9. So I'm going to put 9. Is ADC A to D to B to C, A to D to B to C to A negative edge weight cycle? No. I wonder if this is wrong. Okay, check. Oh, okay. All right. Oh, one more. Okay, what's this one? Select all the negative edge weight cycles. Okay. Is C, let's see, get rid of this. So CBC CBC equals from C to B is 6, back to C again is 5. So it's a 6 plus 5 equals 11. No, that's not negative. How about BDA? B to D is from there to there is -9 equals -9 plus that's B to D, and then D to A is -1 plus -1 equals -10. That would be a negative edge weight cycle. How about B B to D is -9, and then D to E is 2 plus 2, and then E to B is +3. +3 equals -4. That is a -1. Let's see, B to D to E to B. Yes. All right, that's negative. What about A to B? A to B is -6. And A to B to C, B to C is +5. And then B to A to B to C, back to A again. Why is this checked already? A to B is -6. B to C is +5, and C to A. C can't go to A. E go to B. C to A. So I guess that's not, because C cannot go to A. It's not possible. So I'm not going to check it. C to A is not possible. Okay. Okay, how's that? Not possible. How about B to A? Wait a minute. B to A is not possible. B to A. You can go A to B, but can't go B to A. So B to A is not possible. So I'm just going to say it's these two. What's the answer? B, okay, I got that one wrong because B to D it's got to be a cycle. That's the problem. It's got to be a cycle. It's not just a path, it's a cycle. So yes, obviously. Let's do it again. All right, let me erase this. The first one is C to B is -3. To D, B to D, B to D is +3. C to B, B to D, and then back to C again. D to C is 7. To C is 7. And that equals 7. So it is not a negative edge weight cycle. How about E to C? E to C is -8. C to A is +6. And then A back to E is -4. Oh, A to E. There is no A to E, is there? So we're going to just cross that out. So it's not valid. What is the next one? E to C to B is not a cycle. E, C to B, not a cycle. Not going to catch me on that one now. How about A to C is 2. to B is C to B is -3. B to E. B to E is -7. And E back to A again is -4. Okay, let's get this right. A to C is +2. A to C +2. And then C to B is -3. And B to E is -7. And E to A is -4. And it's a cycle. So, and that's a minus number. So yes, that is definitely a negative edge weight cycle. How about, it's going to be less than 0. How about C to B is -3. And then B to E is -7. And then E to A is -4. -4. This is C, B, E, A. And then back to C again. A to C is 2. Is 2. And this is definitely less than 0. So we got minus, let me make this better. Plus. So we got C to B is -3, C to B -3, B to E is -7, E to A is -4, A to C is +2, and it's a cycle. Okay, so this one is also a negative weight cycle. What's the answer? Yes. All right, so I have taken you through, I've done the section 21.11 on weighted graphs. Hope this helps. Thanks for watching.